The next thing about lists is that they are mutable. So let's take a look at what this means. And this is a very important Python concept, so pay attention. The idea of mutability, we talked about this before as well a little bit, is that the contents of whatever thing you're pointing to can be changed in place. So what this means is that if we have a list x equals 1, 2, 3, 4, and we do x0 equals 8, then what's going to happen is that this 1 over here is going to be replaced by the 8. So it's changeable. And the key in understanding mutability and immutability is that an immutable object is that data objects cannot be changed. And in Python, the idea is that if you have a number 5, it's always going to be the number 5. It's never going to change. If you have number 64.3, it's always going to be that. If you have a character h, it's always going to be the character h. They can't be changed, so they're immutable, so we don't allow them to be changed. On the other hand, there are things that can be changed. If I have a list of students who are enrolled in this class and somebody drops out, I still have a list of students enrolled in this class, except that its value has changed. So that list should be modifiable. People are going to drop out, people are going to add in, and the list is going to change. So it should be modifiable, therefore that's mutable. And that's the basic idea. And this mutability and immutability then go on. Let's try a few examples over here and see what happens. It's an interesting thing in Python. And we see that it has consequences, especially with function calls and various kind of things. But let's take a few examples and see. So here we have, in our first example, we have y equals a and b. It's a list containing two elements, the character a and the character b. And we have a list x that contains three elements. It contains the integer 1, it contains a list y, and the integer 3. When you say the list y, what we mean is it's the value of y that goes in over there. So if I print x and I print y, then I'm going to see that x will be, and let me do that here. So let's do this. So we see that x actually is 1, the list a, b, and 3, and y is a and b. Okay. So now let's see what happens if we change the value of y, because it's a list, it's mutable. So I can replace y1, which is the character b, with the number 4, okay, the integer 4, and then I print y. So y now becomes the character a as in the first element, the 0th place, and the integer 4 in the 1th place of this thing. What happens to x though? Because x we saw was, when we looked at it, had these values, right? It had 1, a list a, b, and 3. But this list a, b is actually the list y, right? It's not a list a, b, it's a list y, because that's what we gave it. So this is what y is. And we change y, so what happens is that x will also change. And we see that's right. X is now contains a4 rather than ab, and the reason is because the address in memory of where y is and where the middle part of x is, what's in location 1 of x is the same location. So if you change that, it's going to change in both. Okay, that's the idea there. So that's what mutability really buys us. Let's take a look at some more examples. And here what we'll do is we'll look at the addresses and how they change. So let's say we have a string hello. Now remember, strings are not mutable. Okay, they're immutable. And I look at the value of the string itself and its location, and then I add to that the word u. Okay, so I do x plus equals u. I'm doing an augmented assignment, and then I print x and idx. So that's for the string part, right? So that's what this does over here. Then I have a list that contains a hello, and I look at the address of that list, and then I extend the list by putting a u at the end, and this plus equal to is similar to the extend function. It's going to extend the list, and then I print that. So let's see what the difference between these two situations is. So in the first case, hello was at this location. When I added the u, the location changed. Essentially what we've got is a new string. So the old hello is still at wherever it was, and the new hello u is at a different location. So we haven't actually changed the string. What we've done is we've created a new string, and we are pointing our variable at that new string. That's what this is telling us. From this value, we're now pointing it at this memory address. In the case, remember, the ID function gives you the location in memory of a variable. In the second case, we have a list hello, list that contains the element hello, and that's at this location. Then we extend it by adding the word, by adding a list, that the elements of a list that contains the word you in it. So now we get a list here that says hello you, but look at where it is. It's in exactly the same location, and that's because a list is mutable. So when we say it's mutable, it changes in place, whereas a string is not mutable. So if you want to change it, you're going to have to create a new string to change it. That's the basic difference. So this can be kind of confusing, and it has certain issues. The fact that some things are mutable and some things are not mutable has certain effects on the way the program runs. And so here let's take it's a very quintessential example of what they call gotchas in Python. So here's a gotcha, and what it says is we have a function called eggs, and eggs has two arguments. It takes something and a variable called item, and it has another something which defaults to the value 0. All right, and what we do is we add to total the value of item. Right, so if we call eggs without specifying total, then we call it with one argument, then total will default to 0, and we return total. And we have a second function called spam, which takes an element, some element, and it takes a list instead of an integer. It takes a list as a default second argument. So the second argument is some list, and it's going to default to the empty list. And then here we do sumList.append elem, so we append that and return sumList. So what's going to happen here is that if we call the function with just elem, if we call spam with only the value of elem, then sumList should default to an empty list. So let's see what happens over here. So first we're going to call eggs with the argument 1. So what should happen is item should be 1, total is 0. So total plus equals item should return 1, right? And then we call eggs with 2, and again we should see the same thing. So I'm going to just comment this out so we can see the effect of the integer default. And oops, I have to run that, right? So I didn't run that. So what we get here is when I call eggs with 1, then item is 1, total is 0. So total is 1 plus 0, and we return total, and we get a 1 printed. Then I call eggs with 2, item is 2, total defaults to 0, and 2 plus 0 is 2, so I return 2 and I get a 2, right? So that's how that works. Now let's see what happens if I try this with spam instead. So I'm going to call spam with 1. So now elem is 1, and sumList is an empty list, and I run that here. So here something odd happens, right? So when I call spam with 1, then I get 1 back, which is what we expect, because sumList is an empty list. So it's going to default to an empty list. We're going to append the number 1 to the empty list, and we get a list containing 1. That's great. When I call it a second time, however, rather than sumList, I'm still not specifying sumList. I'm saying I'm calling it now with spam2, right? So I'm not specifying the value of sumList. So you would assume that sumList will default to the empty list, but it doesn't. It defaults to what the previous value of sumList was, because that's now been defined. And what's happening now is that, and I'll explain this in a second again, but what's happening now is that instead of sumList being the empty list, it becomes the list 1, because we've already created it and it already has a value. And when I append something to that, I get the list 1, 2. So when we do this here and we call the function spam, then the first time we call the function, Python is going to set up a little namespace for spam. So it's going to say, here's spam, and this contains elem and sumList. All right, and sumList is going to now point to a list somewhere, and that list will be whatever it is at the end of this thing here. The second time I call it, it says, hey, I already have this definition over here. I have this definition here, so I'm going to use that. And in this definition, I have elem, which is coming from the function call. So elem is coming from the function call, and I have a sumList that points to a list. So I'm going to use that because that's already there. This list contains a 1, so that's already there, right? So now it says, okay, I'm going to use that. And when you say append, it appends to this, and that's why it'll keep getting appended to that. Whereas the total, because total is a immutable object, each time it creates a new total, because you can't change the existing total. It's going to create a new total. That's the the difference between the two. So that's mutability, and it's kind of an important Python concept, so it's well worth getting your head around that. So I would play around with a few examples and check what that does here.